Well then, question 8 gives us the wingspan and the speed. First things first, we want to work out we're going to say, well, what's flux is being cut per second? We need to know the area. So, of course, it's going to be the width of the wings times by the distance travelled in a second. To do that, we have to convert 1,000 kilometers an hour into meters per second. So that's 1,000 divided by 3,600. That gives 227.7 recurring meters per second. So that's the distance times by the area times by the field strength, the component of the field strength anyway, and that gives us 0.52 Webers. B, determine the magnitude of the potential difference. Well, Faraday's law tells us that the rate of change of flux density is the EMF. So it's basically, that's what's happening. That's how much flux is being cut in 1 second. So it's basically going to be that in 1 second. It's 0.52 volts. And the law, stating the law you're applying, and that's the key thing, is Faraday's law. All right. What would be the change if the aircraft flew due west? Well, it's a strange one to answer this. If you think of the pencil here, if this was, say, the positive end of the wings, it would make no difference. If you're doing that, it'd be the positive end of the wings. It would still be the positive end of the wings. But basically, if you're thinking, well, this is the positive end if it's flying west, the opposite end is the opposite direction is the positive end if you fly east. So it would reverse direction, the EMF would reverse direction, but you could also say it would stay the same relative to the wings. All right. Okay, that's question